March 11th, 1945, 0730 hours, Kummersdorf Proving Grounds, 40 kilometers south of Berlin, coordinates 52.1 degrees north, 13.4 degrees east. Hauptmann Ernst Bärkmann walked across the frozen test range toward the machine that represented everything wrong with his understanding of armored warfare. The M26 Pershing sat in the morning light, its hull painted in American olive drab, white star still visible on the turret side. Behind him, a Tiger II from his own battalion waited. Its 88mm gun pointed skyward, its Maybach engine idling with the deep rumble he'd known for 2 years. The Pershing had arrived at Kummersdorf 6 days earlier, captured intact near Cologne when its crew abandoned it after throwing a track. German recovery teams had it operational within 48 hours, a testament to American engineering. Everything worked. The transmission, the suspension, the gun systems, no special tools required, no temperamental components. It simply worked. Bärkmann had exactly 90 minutes of fuel. 90 minutes to answer the question that kept every German Panzer commander awake at night. How had America, a nation that couldn't build a competitive tank in 1942, produced something that made the Tiger obsolete in just 3 years? He didn't know that what he was about to discover would reveal not just a performance gap, but a fundamental difference in how two nations approached armored warfare. By March 1945, the war in the West had reached its final phase. American forces had crossed the Rhine. Soviet armies were 70 kilometers from Berlin. Germany's Panzer divisions, once the terror of Europe, were shadows of their former strength. But the tanks themselves, the Tigers, Panthers, and King Tigers, these were still formidable weapons. Or so German doctrine insisted. The Tiger I had entered service in August 1942. It was revolutionary. The 88mm Keb UK-36 gun could penetrate any Allied tank at ranges exceeding 2,000 meters. Frontal armor was 100mm thick, proof against most Allied anti-tank weapons. It weighed 57 tons, required constant maintenance, consumed fuel at catastrophic rates, and broke down frequently. But when it worked, it was lethal. Statistics from 1944 told a complicated story. Tiger I equipped units claimed kill ratios as high as 10-1 against Allied armor. But they also reported that 60% of Tiger losses came from mechanical breakdown, not enemy fire. The tanks simply couldn't sustain operations. Transmission failures, engine fires, track breakage. For every Tiger destroyed in combat, 2 more were abandoned by their crews when they broke down and couldn't be recovered. The Tiger II, introduced in January 1944, was supposed to solve these problems. It didn't. Heavier at 68 tons, with thicker armor and a longer 88mm gun, it was even more prone to breakdown. Its Maybach HL 230 engine, the same unit used in the lighter Panther, was simply underpowered for the weight. Maximum speed was 25 miles per hour on roads, less than 10 miles per hour cross-country, and fuel consumption was nightmarish. 500 litres to travel 100 kilometres. By March 1945, fuel shortages meant most Tiger IIs were being used as static pillboxes, not because of tactical doctrine, but because there wasn't enough fuel to move them. German Panzer doctrine had been built on these assumptions. Superior gun range, superior armor protection, superior optics, and superior crew training could overcome numerical inferiority. Engage at long range. Use the 88mm gun's penetration advantage. Destroy enemy tanks before they could close to effective range. This doctrine had worked brilliantly in 1940 and 1941 against French and British tanks. It had worked reasonably well in 1942 and 1943 against Soviet T-34 seconds and KV-1 second. But by 1944, it was failing. American Sherman tanks were appearing in overwhelming numbers. British Fireflies with 17-pounder guns could penetrate Tiger armor. Soviet IS-2 heavy tanks mounted 122mm guns that could crack any German tank open. And now there was the Pershing. Intelligence reports on the M26 had been fragmentary. The first Pershings arrived in Europe in January 1945, only 20 tanks assigned to the 3rd and 9th Armoured Divisions. German reconnaissance units had spotted them near Cologne in late February. Combat reports were confusing. One Pershing had reportedly destroyed a Panther at 900 meters. Another had taken multiple hits from a Panzer IV and continued fighting, but hard data was scarce. What was the armor thickness? What could the 90mm gun penetrate? How reliable was the mechanical system? Ernst Bärkmann understood this context better than most. At 33 years old, he had been a Panzer officer since 1939. He'd fought in Poland, France, Russia, and now Germany itself. He'd commanded Panzer IEs, Panzer IVs, Panthers, and for the last year, Tiger IIs. He'd seen German armor doctrine evolve from the Blitzkrieg victories to the desperate defensive battles of 1945. His current assignment to the Kummersdorf weapons testing facility had come in February, after his Tiger II company was effectively destroyed in the Ardennes offensive. Not destroyed in combat, destroyed by mechanical breakdown and fuel exhaustion. Of 18 Tiger IIs that started the offensive, 14 were abandoned when they ran out of fuel or broke down. 4 made it back to German lines. Kummersdorf had been Germany's primary weapons testing facility since 1929, a sprawling complex of test ranges, workshops, and proving grounds where every German tank, from the Panzer I to the Maus, had been evaluated. By March 1945, Allied bombing had damaged much of the Dum infrastructure, but the ranges remained operational and the mission continued. Test captured enemy equipment, identify weaknesses, develop countermeasures. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The night before the test, Bärkmann reviewed intelligence files on American tank development. The progression was striking. In 1942, America's primary tank was the M3 a hastily designed stopgap with its main gun mounted in a hull sponson. Awkward, tall, vulnerable. German crews called it a rolling coffin. By 1943, the M4 Sherman had replaced it. Better, but still inadequate. The 75mm gun couldn't penetrate Tiger armor from the front at any practical range. Frontal armor was only 51mm, easily defeated by the 88mm gun. German intelligence estimated Sherman combat losses at 70% in tank versus tank engagements against Panthers and Tigers. But America produced them by the thousands. Intelligence estimates suggested total Sherman production exceeded 40,000 units. For comparison, total Tiger I and Tiger II production combined was fewer than 2,000 tanks. The Americans could afford losses. They simply brought more Shermans. Germany couldn't match that production. The Maybach factories were bombed repeatedly. Steel allocations were insufficient. Skilled labor was scarce. By late 1944, monthly German tank production of all types had fallen to fewer than 300 units. American production was exceeding 2,000 tanks monthly. The M26 Pershing represented something different. It wasn't a stopgap or a mass-produced medium tank. Intelligence reports suggested it was specifically designed to fight German heavy tanks. The 90mm gun, derived from anti-aircraft artillery, armor up to 100mm on the front, weight 42 tons, heavier than a Sherman but lighter than a Tiger. Most concerning, American industry had developed it in less than 2 years from prototype to battlefield deployment. German heavy tank development took 4 to 5 years. Bärkmann's test plan was methodical. He would evaluate the Pershing across every metric that mattered in combat: mobility, gunnery, armor protection, crew ergonomics, reliability, then compare each metric against the Tiger II's performance. The test would take 90 minutes, limited by fuel capacity and range safety protocols. He understood the stakes. If the Pershing was truly superior to the Tiger, it meant German armor doctrine had been rendered obsolete, not by better tactics or superior crew training, but by industrial capacity. America had simply out-engineered Germany. At 7:15 hours, he began his pre-combat inspection of the Pershing. Walking around the hull, he immediately noticed differences from German design philosophy. The hull was lower than a Tiger's, only 109 inches tall compared to The Tiger II's 123 inches. Lower silhouette, harder to spot, harder to hit. The tracks were 23 inches wide, rubber-backed, and the suspension used torsion bars, not the interleaved road wheel system Germans favoured. Simpler, easier to maintain, less prone to freezing mud jamming the wheels. The turret was rounded, well sloped. Armour plates were cast and rolled, not face-hardened like German armour, but the sloping improved effective thickness. The 90mm M3 gun was shorter than the Tiger II's 88mm KWK-43, but the bore was larger. Penetration would depend on ammunition and muzzle velocity. The engine compartment was compact. The Ford GAF V8, 500 horsepower, less than the Maybach's 700 horsepower, but the Pershing weighed 26 tons less than a Tiger II. Power-to-weight ratio would be better. At 7:30 hours, Bärkmann climbed into the commander's cupola. The first surprise was the crew space. The turret interior was spacious, significantly more room than a Tiger's cramped fighting compartment. The commander's station had 6 vision blocks, providing panoramic visibility. The gunner had a periscope sight, clearly marked, easy to use. The loader had ample room to move. Ammunition racks held 70 rounds of 90mm, well positioned for fast loading. He examined the fire control system. A coincidence rangefinder, an M10 periscopic sight for the gunner, a ballistic computer, crude by German standards but functional. The gun controls were hydraulically assisted. The gunner could traverse and elevate without physical strain. German Tigers used manual traverse, requiring significant effort. Bärkmann settled into the commander's seat and signalled the driver. The Ford GAF engine started with a smooth, powerful rumble. No temperamental starting procedure, no choking or hesitation. It simply started. The driver, a German technician who'd spent 3 days learning the controls, engaged the transmission. Hydromatic, automatic, no manual shifting required. The Pershing rolled forward smoothly. No jerking, no gear grinding, just smooth acceleration. 7:38. Minute 8. Initial mobility assessment. Bärkmann directed the driver onto the test range's cross-country course. Obstacles, ditches, hills, the standard evaluation route. The Pershing moved with surprising agility. The torsion bar suspension absorbed rough terrain smoothly, no violent pitching like a Tiger experienced. The driver reported the steering was light, responsive, no fighting the controls. They crossed a 1.5-metre ditch at speed. The Pershing barely slowed. A Tiger would have required careful approach and precise timing. They climbed a 35-degree slope. The engine didn't strain. A Tiger II couldn't have made that climb without risk of transmission failure. Maximum speed on flat ground, 40 miles per hour. The Tiger II managed 25 miles per hour, and only on good roads. The mobility advantage was overwhelming. Bärkmann understood immediately that this changed battlefield dynamics. A Pershing could reposition faster, flank slower German tanks, choose engagement ranges. Mobility was survivability. 7:52. Minute 22. Gunnery evaluation. Bärkmann ordered the driver to stop at the firing line. Range: 800 meters. Target: a captured Panther hull, positioned at a 30-degree angle to simulate combat geometry. The test would determine if the 90mm gun could defeat Panther armor at typical engagement ranges. He loaded an M82 armor-piercing shell into the breech. The round weighed 24 pounds, manageable for one man. German 88mm rounds weighed 23 pounds, similar. But the M82's tungsten carbide penetrator was designed specifically for defeating thick armor. Bärkmann took the gunner's position. He peered through the M10 sight, adjusted for range, centered the reticle on the Panther's frontal hull. The hydraulic controls made fine adjustments effortless. He squeezed the trigger. The 90mm gun roared. The recoil was sharp but controlled. The muzzle brake absorbed much of the force. Through the sight, Bärkmann watched the tracer impact. Direct hit. Center mass on the Panther's glacis plate. He exited the Pershing and walked to the target. The M82 round had punched completely through the Panther's 80mm frontal armor, angled at 55 degrees, effective thickness of approximately 140 millimeters, penetrated cleanly. He calculated the implications. The Panther's armor was considered excellent protection against most Allied guns. The British 75mm couldn't penetrate it from the front. The Soviet 85mm struggled at ranges beyond 500 meters. The American 76mm Sherman gun was ineffective beyond 600 meters, but the Pershing's 90mm had defeated it at 800 meters. Bärkmann returned to the Pershing and loaded a second round. This time, the target was a Tiger I hull section, 100 millimeters of frontal armor, positioned perpendicular to the line of fire. Range, 1,000 meters. He aimed carefully, adjusted for the increased distance, fired. The round impacted high on the glacis plate. He examined the result. Clean penetration. The tungsten penetrator had defeated 100 millimeters of face-hardened steel at 1,000 meters. The Tiger's frontal armor, long considered proof against most threats, was vulnerable to the Pershing's main gun at combat ranges. The tactical implications were staggering. For 3 years, German armor doctrine had relied on the Tiger's invulnerability from the front. Engage at long range. Let the 88mm gun do its work. The enemy couldn't hurt you if you fought properly. That assumption had just been shattered. The Pershing could hurt you. From the front. At 1,000 meters. The engagement geometry had fundamentally changed. 8, minute, 38. Comparative penetration tests. Reposition. The next phase would test the Pershing's armor protection against German weapons. 3 Tiger II rounds had been positioned at the range. Standard Panzer granite 39/43 armor-piercing shells. Each weighed 28 pounds and could penetrate 180 millimeters of armor at 1,000 meters, according to factory specifications. A technician crew would fire 1 round at a Pershing hull section from 800 meters. The goal: determine if Tiger guns retained their penetration advantage. Bärkmann observed from a protected position as the Tiger II's 88mm Qua 43 fired. The distinctive crack echoed across the range. The round struck the Pershing's frontal glacis, angled at 46 degrees. He examined the impact point. The shell had penetrated, but barely. The hole was clean, but the penetrator had fragmented after passing through. Effective thickness of the sloped 100mm armor was approximately 145mm. The Tiger gun had defeated it, but without the margin of superiority German doctrine assumed. A second test, this time against the Pershing's turret front. Thickness, 114mm. The Tiger round fired. Impact, no penetration. The shell had cracked the armor, creating spalling on the interior, but the penetrator failed to pass through completely. The cast armor construction, dismissed by German engineers as inferior to face-hardened plate, had actually performed better than predicted. Bärkmann understood what this meant. In a frontal engagement between a Pershing and a Tiger II at 800 meters, both tanks could penetrate each other's armor. The Tiger's supposed invulnerability advantage had evaporated. Worse, the Pershing's superior mobility meant it could dictate engagement range, reposition faster, and exploit flanking opportunities the sluggish Tiger II couldn't counter. 8:24, minute 54. Armor, philosophy, comparison. Bärkmann walked between the Pershing and the waiting Tiger II, comparing design approaches. The differences revealed 2 fundamentally opposed philosophies of armored warfare. The Tiger II represented the German approach. Maximum armor thickness, maximum gun penetration, accept the weight penalty, accept the mobility cost. The tank was a mobile fortress. Survive through protection, kill through firepower. The Pershing represented the American approach. Balanced protection, adequate firepower, prioritize reliability and mobility. The tank was a cavalry weapon. Survive through speed and maneuverability, kill through positioning and numbers. German engineers had optimized for the perfect shot, the long-range duel where superior optics and gun performance decided the outcome. American engineers had optimized for the imperfect battle, the chaotic close-range engagement, where mechanical reliability and crew survival mattered more than marginal performance advantages. The Tiger II's interleaved road wheel suspension provided excellent ride quality, but a single damaged wheel required removing, 5 others to replace it. Maintenance time, 8 to 12 hours. The Pershing's individual torsion bar suspension allowed wheel replacement in under 2 hours. The Tiger II's Maybach engine produced 700 horsepower, but required high-octane fuel, precise maintenance schedules, and constant monitoring. The Pershing's Ford engine produced 500 horsepower on standard gasoline, required minimal maintenance, and simply worked. The Tiger II carried 92 rounds of 88mm ammunition in complex racks, requiring careful loading procedures. The Pershing carried 70 rounds of 90mm in simple racks any crew member could access. Every German design choice prioritized performance. Every American design choice prioritized practicality. In 1940, when Germany fought limited campaigns with intact logistics and ample maintenance time, the German approach had worked brilliantly. In 1945, fighting a multi-front war with collapsing logistics and no time for maintenance, the American approach was superior. 8:39. Minute 69. Crew ergonomics assessment. Bärkmann climbed back into the Pershing's turret and spent 15 minutes examining crew positions. The commander's cupola provided visibility German tanks couldn't match. 6 vision blocks offered 360-degree observation without exposing the commander's head. The gunner's station was logically arranged, all controls within easy reach. The hydraulic traverse meant a single gunner could engage targets quickly without physical exhaustion. German Tigers required both gunner and commander to manually traverse the turret on targets beyond 45 degrees. Time to traverse 90 degrees. Pershing with hydraulics, 6 seconds. Tiger II with manual traverse, 20 seconds. In combat, those 14 seconds were the difference between first shot advantage and being shot first. The loader's position was spacious. Ammunition racks were positioned for natural movement. A trained loader could maintain 8 to 10 rounds per minute sustained fire rate. German loaders in cramped Tigers managed 6 to 7 rounds per minute, and that rate degraded as they fatigued. The driver's station impressed Bärkmann most. The automatic transmission meant the driver focused entirely on navigation and obstacle avoidance, not gear selection. German drivers constantly managed manual transmissions, particularly stressful during combat maneuvering. American drivers simply pointed the tank and drove. The psychological advantage was significant. Less crew fatigue meant better decision-making in extended engagements. Simpler controls meant shorter training time. More forgiving systems meant fewer catastrophic operator errors. German tanks required expert crews. American tanks worked adequately with average crews. In a long war of attrition, that difference was decisive. Nuller cased 5 acts, minute 88, final assessment, battlefield reality. Combat simulation. A meeting engagement at 600 meters. The Pershing versus a stationary Tiger II target. He would evaluate how quickly the Pershing could acquire, engage, and destroy a German heavy tank from a cold start. The Pershing rounded a berm at 15 miles per hour, simulating a combat approach. The Tiger II hull appeared 600 meters ahead. Bärkmann called, "Target, tank, 12 o'clock." The gunner responded immediately. Hydraulic traverse whined as the turret swung onto target. 3 seconds. Identified. The gunner had acquired the target through his periscope sight. Range 600. Bärkmann confirmed with his rangefinder. Fire when ready. The 90mm gun fired. Time from target acquisition to shot, 11 seconds. The M82 round struck the Tiger II's frontal hull and penetrated completely. Bärkmann ran the comparison in his mind. A Tiger II crew executing the same drill would require 5 seconds for commander identification, 8 seconds for manual turret traverse, 5 seconds for range estimation and gunner acquisition, 3 seconds for final aiming. Total, 21 seconds. The Pershing crew was 10 seconds faster. 10 seconds. In that time, the Pershing would fire, penetrate, destroy the Tiger, and be repositioning for the next target. The Tiger crew would still be aiming their first shot. This was the revelation Bärkmann had been dreading. It wasn't that the Pershing was dramatically superior in any single category. The armor was roughly equivalent. The gun was roughly equivalent. The mobility was better, but not overwhelmingly so. What made the Pershing superior was the integration. Every system was designed to work together. Hydraulic gun controls allowed faster engagement, better crew ergonomics reduced fatigue. Reliable mechanics meant the tank was operational when needed. Simpler maintenance meant broken tanks returned to service quickly. The Tiger II was a precision instrument. When everything worked perfectly, it was lethal. But everything rarely worked perfectly. The Pershing was a practical tool. It worked adequately under terrible conditions, with tired crews, with minimal maintenance, with average training. And in March 1945, terrible conditions were all that existed. 9. Minute 90. Conclusions. Bärkmann shut down the Pershing's engine and sat quietly in the commander's cupola. The morning sun had burned off the frost. The test range was silent except for wind through the damaged buildings. He had his answer. The M26 Pershing hadn't made the Tiger obsolete through revolutionary technology. It had made the Tiger obsolete through evolutionary competence. America had taken 3 years to learn what Germany knew in 1940, how to build an effective heavy tank. But they'd learned it with advantages Germany never had: unlimited resources, intact factories, secure supply lines, and time to refine the design. The 90mm gun rendered the Tiger's armor advantage meaningless. The hydraulic systems rendered the Tiger's manual controls obsolete. The automatic transmission rendered the Tiger's complex drivetrain a liability. The simple, robust construction rendered the Tiger's precision engineering a weakness. And most devastatingly, American industry could produce Pershings at scale. Intelligence reports suggested production capacity of several hundred per month once full production began. Germany was building fewer than 50 Tigers monthly, and that number was falling as factories were bombed and raw materials became scarce. Even if German crews were better trained, even if German tactics were superior, even if German fighting spirit was unbreakable, none of it mattered when the enemy could field 5 tanks for every one you could produce. Bärkmann climbed down from the Pershing and walked toward the technical office. His report would take hours to write. 14 pages of measurements, performance data, tactical analysis. But the conclusion would be brutally simple. The M26 Pershing is equal or superior to the Tiger II in every category that matters for sustained combat operations. Its 90mm gun defeats Tiger armor at practical engagement ranges. Its armor resists Tiger fire at equivalent ranges. Its mobility, reliability, and crew ergonomics are significantly superior. Most critically, American industrial capacity can produce Pershings in numbers that make battlefield losses irrelevant. German heavy tank doctrine assumed qualitative superiority could overcome quantitative inferiority. That assumption is no longer valid. He would submit the report through proper channels. It would go to the Waffenamt, the weapons office, then to OKW, the Armed Forces High Command, and eventually it would reach someone who might have the authority to act on it. Not that action was possible. Germany didn't have the resources to design a new tank, didn't have the factories to build it, didn't have the fuel to run it, didn't have the time. The meeting took place 4 days later, in what remained of the Heereswaffenamt headquarters in Berlin. The building had been hit by Allied bombers in February. Temporary offices occupied the undamaged south wing. Bärkmann arrived at 0900 hours on March 15th, carrying his report in a leather portfolio. The officer who met him was Oberst Heinrich Müller, head of the Panzer development section. At 52 years old, Müller had overseen German tank development since 1938. He'd been instrumental in the Tiger and Panther programs. He was also a realist who understood that Germany had already lost the war. Müller gestured to a chair in his cramped office. "I've read your report, Hauptmann. Twice. Your conclusions are troubling." Bärkmann said nothing. He'd written what he'd observed. There was nothing to defend. Müller continued. "You state that the Pershing's 90mm gun can penetrate Tiger armor at 1,000 meters. You're certain of this. Measurement. The test results are documented with photographs and impact analysis. The M82 armor-piercing round defeated 100 millimeters of face-hardened steel at that range, cleanly. And you conclude that our Tigers have lost their armor advantage. At practical combat ranges, yes. The engagement geometry has changed. Both tanks can now penetrate each other frontally between 600 and 1,200 meters. Müller leaned back in his chair. You understand what you're saying? For 3 years, we've told our crews that Tiger armor is invulnerable from the front, that they can engage with confidence at long range. You're telling them that's no longer true. I'm telling them the truth. The Americans have closed the performance gap, their production has overwhelmed the numerical gap, and their operational reliability has eliminated our theoretical advantages. Your section on crew ergonomics suggests American tanks are easier to operate. They are. Hydraulic gun controls, automatic transmission, spacious crew compartments. An average American crew in a Pershing can achieve faster engagement times than an experienced German crew in a Tiger. Müller was quiet for a long moment. Then he said, You mention production numbers. You estimate American Pershing production at several hundred per month. That's based on intelligence reports of their factory capacity. They built 40,000 Shermans in 3 years. If they apply the same industrial methods to the Pershing, they'll produce them faster than we can destroy them. And you believe this makes continued heavy tank development pointless? Bärkmann chose his words carefully. I believe that Germany lacks the resources, time, and industrial capacity to match American tank production. Even if we designed a tank superior to the Pershing, we couldn't build enough to matter. The Americans would simply produce 10 Pershings for every Tiger we fielded. Müller opened a drawer and pulled out another document. I received a similar report last month. From a test pilot at Rechlin. He flew a captured P-51 Mustang and concluded that the FW-190D was inadequate against American fighters. His report was classified top secret and suppressed. Do you know why? Bärkmann shook his head. Because honest assessments of enemy capabilities are considered defeatist. Because admitting that American equipment is superior contradicts 3 years of propaganda. Because the truth is uncomfortable. Müller slid Bärkmann's report across the desk. Your technical observations are noted. Your measurements are accurate. Your conclusions are sound. But this report will be classified and restricted to essential personnel only. You're burying it. I'm preserving it. There's a difference. When this war ends, and it will end soon, someone will need to understand what happened, why Germany lost. Your report will be part of that record. What about operational units? Don't they deserve to know what they're facing? Müller's expression hardened. Operational units are fighting with whatever tanks we can still field. Most of them are Panzer IVs and obsolete equipment. The few Tigers we have left are being used as static defensive positions because we don't have fuel to move them. Your report won't change their situation. It will only confirm that they're fighting a war that's already lost. Bärkmann understood. The report was being acknowledged but neutralized, not because it was wrong, but because it was too honest. He stood to leave. Müller stopped him. One more thing, Hauptmann. You're being reassigned. There's a Panzer training unit in Bavaria that needs experienced instructors. You'll report there next week. Training unit? We're training crews for tanks we can't build with fuel we don't have. We're keeping experienced officers alive. You've survived 6 years of war. You have knowledge worth preserving. Go to Bavaria, train the young men, and when this war ends, remember what you learned. Bärkmann left Berlin that afternoon. He never saw his report again. But like the Rechlin test pilot's assessment of the P-51, Bärkmann's report had a strange afterlife. Copies circulated through unofficial channels. Panzer commanders shared information that official command wouldn't provide. By April 1945, German tank crews who had never seen a Pershing knew its capabilities. The knowledge didn't help. They still had to fight with whatever equipment remained. The combat record validated Bärkmann's analysis with brutal efficiency. Between February and May 1945, American Pershing-equipped units encountered German armor in dozens of engagements. At Cologne on March 6th, a single Pershing destroyed a Panther and a Panzer IV in a running gun battle through city streets. At Dessau on April 18th, 3 Pershings engaged 5 Panthers at ranges between 600 and 1,000 meters. The Pershings destroyed all 5 Panthers without loss. The Panther's mobility advantage in urban terrain was negated by the Pershing's superior acceleration and more reliable transmission. At Kirchheim on May 2nd, 2 Pershings ambushed a Tiger II. The Tiger's 88mm gun fired first and penetrated one Pershing's turret, killing the commander. The second Pershing maneuvered to the Tiger's flank and fired 3 rounds into the side armor. The Tiger exploded from ammunition fire. The exchange exemplified Bärkmann's conclusions. In a perfect engagement, the Tiger could still kill. But perfect engagements were rare. The Pershing's mobility allowed it to force imperfect engagements where German armor advantages disappeared. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Overall, Pershing-equipped units reported kill-to-loss ratios of approximately 3-to-1 against all German armor types. Not overwhelming superiority, but consistent tactical advantage. More importantly, Pershings that were damaged could usually be recovered and repaired. German tanks that broke down were typically abandoned due to fuel shortages and lack of recovery vehicles. By war's end, American forces had fielded approximately 310 Pershings in Europe. German forces had fewer than 200 operational Tigers of all types remaining. The numerical disparity that Bärkmann had warned about had materialized exactly as predicted, but the Pershing's real impact wasn't measured in kill ratios or combat statistics. It was psychological. For 3 years, German Panzer crews had operated with the confidence that their Tigers and Panthers were superior to anything the Allies fielded. Armor protection was adequate. Gun performance was dominant. Crew training was superior. The appearance of the Pershing shattered that confidence. German crews now faced an opponent that could penetrate their armor, match their gun performance, and outmaneuver them tactically. The psychological advantage had shifted. American crews attacked aggressively, knowing their Pershings could fight German heavy tanks on equal terms. German crews fought defensively, conserving fuel, avoiding engagement when possible. The offensive spirit that had characterized Blitzkrieg in 1940 had been replaced by the defensive mindset of inevitable defeat. Ernst Bärkmann survived the war. His reassignment to the training unit in Bavaria kept him away from the final desperate battles in Berlin and Prague. On May 8, 1945, when Germany surrendered, Bärkmann was with a group of instructors and students near Munich. They surrendered to American forces without resistance. Bärkmann spent 18 months in a POW camp. American intelligence officers interviewed him extensively about his experience testing captured equipment. His technical knowledge was valuable. His honest assessments were refreshing. In late 1946, he was released and returned to what remained of his hometown near Hamburg. The post-war years were difficult. Germany was devastated, divided, occupied. But Bärkmann had skills that peacetime valued. He found work as a mechanical engineer with a manufacturing company rebuilding industrial equipment. He never discussed his wartime service publicly. But in 1962, a military historian researching German armor development tracked Bärkmann down. The historian had found references to his Pershing test report in captured German archives. He wanted to know what Bärkmann had observed. The resulting interview became a primary source document. Bärkmann was remarkably candid. When asked about the Pershing test, he said, "The Tiger was a magnificent machine when everything worked, but everything rarely worked. The Pershing was adequate in every situation. In a long war, adequate and reliable beats magnificent and fragile." He elaborated, "German engineers designed for perfection. Every component optimized for maximum performance. But perfection is brittle. One failure cascades into total breakdown. American engineers designed for tolerance. Every component adequate with margin for degradation. Tolerance is robust." The historian asked if Bärkmann believed the Pershing was superior to the Tiger. Bärkmann's response was nuanced. In a single duel, with both tanks operating perfectly, with expert crews, The Tiger might have a slight advantage. Longer gun, slightly better optics. But war isn't single duels. War is sustained operations over weeks and months. Mechanical reliability, crew fatigue, logistics, training quality, production numbers. In all those factors, the Pershing was decisively superior. He added, "The 90mm gun didn't make the Tiger obsolete because it was more powerful. It made the Tiger obsolete because it was powerful enough. Once both guns could penetrate each other's armor, the battle became about everything else. And in everything else, the Americans had the advantage." The historian asked about Bärkmann's report being suppressed. "I understood why they did it. Admitting the truth would have undermined morale at a time when morale was all we had left. But suppressing honest assessment meant commanders made decisions based on outdated assumptions. How many crews died because they believed their armor was invulnerable when it wasn't?" The interview concluded with a question about lessons learned. Bärkmann thought carefully before answering. Industrial capacity matters more than individual excellence. Germany had excellent engineers, skilled crews, sophisticated technology, but America had factories that couldn't be bombed, resources that couldn't be exhausted, and a system that prioritized practical solutions over theoretical perfection. We were trying to win through quality. They won through quantity and adequate quality. In total war, their approach was correct. Modern analysis of the Pershing versus Tiger engagement confirms Bärkmann's assessment. The M26 Pershing was not dramatically superior to German heavy tanks in pure specifications, but it represented a fundamental shift in American tank development philosophy. The Sherman had been adequate for its role, mass-produced medium tank for exploitation and infantry support. But by 1944, American commanders wanted a tank that could fight German heavy armor on equal terms. The Pershing delivered, not through revolutionary technology, but through evolutionary competence. Take the Sherman's reliable drivetrain and improve it. Add armor thick enough to resist German guns. Mount a gun powerful enough to penetrate German armor. Keep the design simple enough for mass production. The result was a tank that finally gave American crews parity with German armor. Not superiority, parity, and parity was enough. Because America could produce them in numbers Germany couldn't match, because American logistics could keep them supplied with fuel and ammunition, because American recovery units could repair damaged tanks and return them to service. The systemic advantages overwhelmed individual performance margins. The lesson extended beyond tanks. Bärkmann's 90-minute test on March 11, 1945, documented something larger than comparative armor performance. It documented the industrial reality of modern warfare. Germany had entered the war with technological advantages in many categories: superior tanks, superior tactics, superior operational art. But industrial warfare wasn't decided by initial advantages. It was decided by sustained production, logistical depth, and systemic resilience. America's industrial base could absorb losses and continue producing. German factories were bombed into rubble. American supply lines stretched across oceans but remained secure. German supply lines collapsed under Allied air attacks. American training programs produced adequate crews in predictable numbers. German training programs were disrupted by fuel shortages and enemy action. Every American systemic advantage compounded every German systemic weakness. By March 1945, the cumulative effect was overwhelming. The Pershing was simply the manifestation of that reality. One test, 90 minutes, a single German officer's honest assessment. The truth was documented. The truth was suppressed. And the truth didn't matter because by March 1945, the war's outcome was already decided. Ernst Bärkmann died in 1984 at age 72. His obituary in the local Hamburg newspaper made no mention of his wartime service. But among military historians and armor enthusiasts, his name is remembered. He was one of the few German officers who tested captured Allied equipment and reported honestly about what he found. His Pershing report, finally declassified in 1973, remains a primary source for understanding comparative tank performance in World War II. The report's conclusion is stark in its honesty. The M26 Pershing represents the culmination of American tank development during World War II. It is not perfect. The armor could be thicker. The gun could be more powerful, the mobility could be better, but it is adequate in all categories that matter. And adequacy, produced at scale, with reliable logistics and sustainable crew training, defeats excellence, produced in limited numbers with fragile logistics and unsustainable losses. The Tiger is obsolete not because the Pershing is dramatically superior, but because war has changed. Industrial capacity now matters more than individual weapon quality. America understood this, Germany did not. That understanding decided the war. 1 test pilot, 90 minutes of evaluation, 14 pages of analysis. Bärkmann flew American aircraft and concluded German fighters were outmatched. Another officer, another test, the same conclusion. The pattern repeated across every weapon system. German. Excellence versus American adequacy at scale. History records which approach prevailed. The M26 Pershing went on to serve in Korea, where it finally met its intended role, defeating heavy enemy armor. Against Soviet-built T-34, 85 seconds, the Pershing was clearly superior. The 90mm gun penetrated T-34 armor at ranges exceeding 2,000 meters. The armor resisted T-34 85mm fire at all practical ranges. American crews called it the tank they wished they'd had in Europe, but by then, tank development had moved on. The M26 pattern, an upgraded Pershing with a more powerful engine, replaced it in 1949. Then came the M47, M48, M60. Each generation larger, heavier, more powerful. The cycle that produced the Tiger, then the King Tiger, then paper projects like the Mouse and E-100, that same cycle drove American tank development for decades. The difference was that American industry could sustain it. Total M26 Pershing production was 2,212 tanks, a modest number by American standards. For comparison, total Tiger 30 and Tiger II production combined was 1,839 tanks, similar numbers, but the Pershing was produced in 18 months, the Tigers took 4 years. The Pershing was produced while America simultaneously built tens of thousands of Shermans, hundreds of ships, thousands of aircraft. The Tigers were produced while German industry struggled to maintain production of anything. That difference encapsulated the industrial reality Bärkmann had documented. Germany could match American capability in individual weapons. Germany couldn't match American capability across the entire spectrum of warfare simultaneously. The Pershing made the Tiger obsolete because it was one component of a military-industrial system that Germany couldn't match. The 90mm gun was important, but equally important were the factories that produced them by the hundreds, the supply ships that delivered them to Europe, the recovery vehicles that repaired damaged tanks, the training centers that prepared crews, the doctrine that employed them effectively. Remove any single component, and the system degraded. But no single component was irreplaceable. That was the American advantage. Systemic resilience. Ernst Bärkmann understood this on March 11, 1945, after 90 minutes in a captured Pershing. He documented it, he reported it, and he watched as the information was suppressed because the truth was too uncomfortable to acknowledge. By the time German command accepted reality, Soviet armies were in Berlin and American armies were across the Elbe. The war was over. The Tiger had been obsolete for months. Everyone just pretended otherwise. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.